Hey guys, welcome back to a new video. In this video, I will give you a full crash course on MVVM because I realized I don't really have that on my channel. Like, yes, I do have a playlist about MVVM, which was my very first YouTube playlist. And I think till then, like 2 years ago, Android changed a little bit and my explanation skills improved a little bit. So I think I will just make an up-to-date crash course, just a single video which will teach you MVVM from the ground up. So what will actually be the prerequisites here? If you want to learn MVVM, that is on the one hand, of course, just Android basics, in this case here, Jetpack Compose. So you should know Jetpack Compose. I do have a playlist about that. You should, of course, know Kotlin. I also do have a playlist about that. And you should watch my MVVM 100 seconds theory video before. So that's where I basically tell you why we use MVVM, what that is, and how it just works together. You can click up here. As I said, in only 100 seconds, you will see how that works. It's a nicely animated video. And after that, you will be ready to jump into practice here in this video. And what is helpful, not necessary to know that in detail before, is Kotlin coroutines, which I also have a playlist about. So if you already know that, it will be helpful, but it's not like a real requirement before you jump into this video here. So if you at least know Jetpack Compose and Kotlin, you are ready to start. And let's actually next go through what you will learn in this course. That will, of course, on the one hand be MVVM. We will make a very simple to-do list app so you can actually learn how all the different parts of MVVM interact with each other. That will be what we will build here. We have a simple floating action button with which we can add a new to-do. You can give it a title like Hello YouTube, an optional description, hello, and then if we click check, then it will be saved in our local database. It is a very ugly app. I know that the UI is really not the focus here, but you will basically learn how we make a simple CRUD app with MVVM, because that's really, I think, the most basic example that teaches you how MVVM works. You can see we can delete this. If we click here, we get a snack bar to do delete it. We can undo this, so it's inserted back. And of course, we can check and uncheck it like we know it from a normal to-do app. And to show you that it's really a database, let's remove this app, relaunch it, and there you go. You can see it's still checked, it's still contained here. And yeah, that's what we're going to build. On the other hand, you will actually also learn Dagger Hilt. So that will be a library for dependency injection. You will learn what that is. I will also explain that from the ground up and just how we can use it with an MVVM project. And of course, as you've seen, we use a local database here. That will be a Room database, which you will also learn. So you also don't need to know anything about Room to jump into this project. So assuming you have actually watched the theory video, the 100 seconds, or you already know why we use MVVM, let's jump into Android Studio. And what you need to make sure is to get the initial project from my GitHub repository down below. That means the dependencies here. I don't need to write these here in this video. So on the one hand, we have Compose dependencies for navigation and ViewModel, Dagger Hilt for dependency injection, Room for our local database, and coroutines extension, or rather Kotlin extensions for Room. So we can use that together with coroutines in a very clean way. And that's pretty much it. Like here in our project file, we include this class path for Dagger Hilt. And like here in the build file, we also use these two plugins that we actually apply. But as I said, you can just get this from my GitHub repository and then you're settled. Let's clear this here and jump right into it. So just as a very quick recap, we use MVVM to give our project a very clear structure. This structure will help us to improve testability, to improve extendability. So how easy is it to add new features to our app, and just how easy it is to understand what we already built. Just for us, but also especially for other people who might work with us together on a project. If your project has a clear structure and everybody in the team knows that structure, it's just very clear where things are when you want to change something. So the end goal should always be to divide our app into 3 layers, which is UI, business logic, and data. Business logic would mean just the pure application logic. Like if you just want to search an element in a list, for example, you loop through it and you just check, okay, is this current element actually, does it contain the search query? That would be an example of business logic, which would be put in the view model. In the data layer, we just access our data sources, which in this case would just be our local database, our room one. But it could also be an API that we access. And that data layer would then provide the data for our view model, and the view model would then put it into state. I will get to all these terms, what that means, and would then provide that state for our UI. So our UI can then in the end display what the view model provides. Sounds super complex if you hear this the first time. I know it actually isn't that complex, but let's jump into it. And I want to start implementing our data layer. So we will actually start creating our room database here at the very beginning. In our root package, we will create a new package called data. And in that, we will create a new Kotlin class of file. So when it comes to databases, especially SQL databases, which Room actually implements, it's an SQLite database, then we first need an entity. An entity is basically the class or the table that contains the data you want to save. So in our case, since we want to save to-do items, this entity, which will be called to-do, will contain all the fields that we want to save with a single to-do item. The first step when we have such an entity with Room is we want to annotate this with entity. So that just tells Room, hey, this is an entity. We want to have that as a table in our database. And in here, we now need to think about what do we want to actually save with a to-do item. On the one hand, that's of course a title, which is a string. Then we have a description. But as you've seen in the app, the description is optional. So we actually need to make this nullable. And if we don't pass a description, then we just pass null here for this to do. And on the other hand, each to-do item actually needs to save if it is already done or not. So val is done, which will be a Boolean here. Now for SQL databases, it's the case that we also need an additional property, which will be the so-called primary key. That will be usually an ID that we save with each item, and that needs to be unique. It will be used to just uniquely identify an item in our database. And we can just call this ID here, will be an integer, and we make this nullable, because in the end it won't be null, but the way Room handles this, if we just don't pass a value here, when creating this entity, Room will automatically generate this ID for us. So we don't need to make sure that we pass a unique one here. We can just annotate this with primary key to tell Room, hey, this should be our primary key. And then we are settled for this entity and ready to jump into the next file. And that will be our so-called DAO object. So in our data package, new Kotlin class of file, and that will be an interface, which will be called to-do DAO. So what the heck is a DAO object? DAO stands for Data Access Object, and it is exactly that. It is used to access our data. So it defines the different ways we want to access our data. So now we just defined what kind of data we have, which are to-do items. Now we want to define how we would like to retrieve and change that data in our database. And that's what we do here. So we basically define the functions we need to interact with our database. So we want to have a function to insert new to-dos. We want to have a function to retrieve all to-dos for our list. We want to have a function to delete a to-do. And we want to have a function to get a single to-do by its ID when we load it in the detail view. So let's actually start with a suspend function insert to-do. So as I said, it's helpful if you know coroutines. This is related to coroutines, this keyword. If you don't know that, it basically means we suspend. So we stop the current function where this is executed in until we actually got the result. So until we actually know that the execution or that the insertion here finished. And that's just a very cool way of asynchronous programming, because we can do this in a sequential way. So it basically gets rid of callbacks. So instead of having a callback that gets triggered when we inserted our to-do, we can make this suspend, and we just wait in the current function kind of to get the result. You will see how this works. We don't need to understand it at this point. We will also have another suspend function, delete to-do, where we pass the to-do we want to delete. We want to have a suspend function get to-do by ID, which will do exactly that. We pass the ID, which is an integer here, and that will now return a nullable to do, because if the ID doesn't exist, we want to make sure the app doesn't crash. And we want to have a function. This is now not a suspend function, get to-dos. So that will just retrieve all to-dos, and that will return a so-called flow of Kotlin X coroutines here. The flow of a list of to-do. So that's a cool thing about Room, that we can return flows, which means that we basically get real-time updates as soon as something in our database changes. So as soon as we inserted to do, deleted to do, or whatever, just change something that would affect this query that we define here, then this flow would trigger again and give us the new and updated list of to-dos. So that's pretty cool. And we're actually not done yet, because how should actually Room know what we want to do? We just have our very own names here. That's cool, but it doesn't know how we still want to access the DB. So on the one hand, we first of all need to tell it that this is actually our DAO object. So we annotate it with that. Then we also need to annotate this insert function simply with insert here. And I actually want to pass a so-called onConflict strategy, which is, yeah, it's a strategy. What should happen if we want to insert a to-do with an ID that already exists? Because in that case, we just want to say onConflict strategy.replace. So if we want to insert a to-do, a new to-do here, and the idea of that new to-do already exists in our database, we simply replace the old one. So then that way we have an insert and update function just in one function, which is pretty cool. For the delete one here, we just annotate it with delete. For get to do by ID, we need to define a custom SQL query to just define how it should get that to do. So we just want to select all the properties from our to do table where the ID is actually equal to the ID we passed. So we do this with this little colon here to refer to the parameter. And here we also have a query. We just want to select everything from our to-dos table. So it's really simple in the end. That's just, as I said, the interface that defines how we access our database. And Room will then worry about all the implementations and generate that code for us. So far, so good. What is the next step? The next step is to define one final class in regards to Room, and that is our actual database instance, which then has an instance of this DAO object to actually access the actual DB. So also in our data package, new Kotlin class, and we call this to-do database. That will be a class, and it will inherit from Room database. It will actually be an abstract class, and we annotate this with @database. Here we need to define two properties. On the one hand, the entities, so just all the tables we have in our DB, which in this case is just the to-do table. So to-do :class. And we also need to define a version, which is just one here, the initial version. Every time you change your database in future, if you have a running app in production, you need to increase this version so Room can actually recognize if it should migrate your data or not. And one more thing in here is that we need our DAO reference, which is also an abstract val, which Room will then automatically kind of insert for us, or it will create that instance for us here. So we can say DAO is of type to do DAO, and then we're settled. So that's really everything for this very simple to do database instance, which we will then later provide with Dagger Hilt. And what that means, you will understand that when we get to that. The next step is to define our repository. If you watched the MVVM in 100 seconds video, then I've also mentioned that we usually, for the data layer in MVVM, use a so-called repository. The job of the repository is just to access all of our data sources. So in this case, we only have a database. but it could also be a database and an API. It could be a database, an API, and some preferences or so. Like all of our data sources. And then the repository's job is to decide which data it should actually forward to the view model. So you can imagine that you have a local cache in your app. Let's say we have like an online API of this to-dos list here. And we would like to save our to-dos remotely as well. So what we could do is, we could have a repository that fetches the data, the new to-dos from the API, and then saves it in the local database as a cache. So we can also use the app offline and then forward that local data to the view model. Sounds quite complex, but in the end, it decides which data should be forwarded to the view model. Like if we have a cache, should we show the remote data? Should we show the local data? Should we show some preference data? That is what the repository is for. So in our data package, new Kotlin class of file, first of all, interface again, which will be called to-do repository. I like to define an interface for that because it just serves as an abstraction. That's usually a good idea to depend on abstractions, not on concretions. So an interface would be an abstraction because that way you're just flexible with your architecture. This on the one hand makes testing easier because you can create your own fake versions of this to-do repository for your tests. Because usually you don't want to test with your actual database or actual API. And on the other hand, you don't need to change all your code in case your repository actually changes, because then you only need to change the implementation of that repository. And this to-do repository will now have a function for each function we have in our DAO. This will look like some dumb boilerplate code we have here, especially in this small app. But for larger project, it really pays off to have that. So we can actually let's just copy this from our to-do DAO because it will contain the same functions, just without annotations. So we can delete these. Make sure to remove the imports. And then we can now actually write the implementations for these functions. So create a new class in our data package, to-do repository implementation, I call it. And this will now implement this to-do repository interface. You can see now we have to implement these functions, pressing Ctrl-I, Ctrl-A, and Enter. And here we now define how we actually get the to-do elements now. We, of course, now need access to our actual database instance. How do we get that? Well, we just pass it to the constructor of this to-do repository. So we actually need the DAO to access our database. So we just pass it there. And here for these single functions, we just say DAO insert to-do and pass our to-do here that we got as a parameter. DAO delete to-do. DAO, actually return DAO get to do by ID, pass the ID, and we can say DAO get all to do's here. We return that. So as I said, that looks really not necessary if we just call these functions from our DAO object, but it really gives it a good structure. You need to think about what happens actually if you extend this with an API. Then these functions here suddenly get more complex. Then a repository really makes sense. In this case, it really doesn't make sense, I know, but since I want to teach you the real way or give you some kind of template you can apply for any project, I want to still show it. Now, that is everything for our data layer. So we now define how we access our database. We have a repository that our future view models can access. What is the next step? The next step is to set up Dagger Hilt. Dagger Hilt is used for so-called dependency injection. What the heck is dependency injection? Well, it's quite complex why this is helpful if you've never heard it, but if it's just about what that is, it's really simple. So in the end, dependency injection is all about giving an object its instance variables. So that means, for example, what we do right here with this to-do DAO, that is dependency injection, because we we pass a dependency. So in this case, this would be the dependency. Don't confuse this with Gradle dependencies. A dependency is just an object specific class depends on. So this to-do repository needs our to-do DAO, so it depends on that. So that is the dependency of our to-do repository. And here, when we pass this from the outside, we inject the dependency. So that is what dependency injection is really about. We say, okay, we pass it here in the constructor. That's called constructor injection. However, there are different ways of injecting dependencies. Another way is using Dagger Hilt, which is a library for that. And Dagger Hilt actually makes all this stuff a lot easier. So we just have a central place where we define all of our dependencies. So in this case, our database and our repository, not much more. But you could imagine that you would also have your API there that you want to provide. You could imagine that you have some kind of maybe glide instance. So for image loading, all that stuff would be put in a central so-called module where Dagger Hilt will basically learn how it can construct these objects to be able to then pass it to all of your different classes in your project, like to your repository, to your view models in the end and all that stuff. So let's actually start with setting it up, and I will explain everything on the fly. In our root package now, let's close our data package. Here we create a new class called to-do app. So when we use Dagger Hilt, we just need to have an application class that inherits from application and that we annotate with Hilt Android app. So that will just give it access to the application to also be able to use the application context to provide some objects and dependencies of us. We then go to our manifest and need to specify that we have an application class by using a name attribute and passing to-do app. And close this again. And now, as I said, we will define the so-called module, which will be the central place where we define how our dependencies are created. So Dagger Hilt actually can inject these into single classes. So here, root package, we create a DI package for dependency injection. And in that, we create a so-called app module. So why is it called app module? Well, there are different modules we could create. Like in a bigger project, you usually have more than just one module. These modules not only define the dependencies we have in our project, but also their lifetime. So there are some dependencies we might not need throughout the whole lifetime of our application. So they don't need to be so-called singletons. Here we do that, but if you maybe have an app that has multiple activities, there might be some dependencies you only need for a single activity. Then you can put them in a single module, which only keeps them alive for the lifetime of that specific activity. But since we don't have that here, we don't do that. Also, by the way, make sure that this is an object, not a class. We want to annotate this with module to tell Dagger, hey, we are going to have a module here, and another annotation will be install in. So this now defines how long our dependencies we define here are going to live. Since, as I said, this is the app module, which contains only singletons. So just dependencies that live as long as our application does. We install this in the so-called singleton component. And then in here, we define with functions how the dependencies should be created. So let's start by defining how Dagger can create our room database. So we can say provides, because this function will provide a dependency, and singleton. So the actual dependency is a singleton. There will only be a single instance that exists of it. Provides to-do database. It will need the application context to be created. So what we need to do is we need to pass it here, just the application. And for the application, Dagger Hilt actually knows how to provide this. So it will do all that behind the scenes. We don't call these functions on our own. That's all Dagger's job. That will now return a to-do database. And we can just construct this the normal way here. Room database builder it is. I think. Actually, our database builder. Just room. I think it's room.database builder. Yeah, this one. Here we need to pass our context, which is app. The class of our database is to-do database class in Java, and the name is just to-do-db, for example. So that's how we just construct a new instance of this to-do database object, which we can then use in the repository to access the database and insert stuff. We then want to call that build, and you can see the errors are gone. Now Hilt knows how it should construct this object to be able to inject it into our single classes. Now we actually need one more dependency that we provide here, not only our database, but also our repositories. So in the end, we will have a central place where we inject these, and that will be our view models. So in the end, we need to think about what do we need in our view models to use our app. And that, of course, are typically the repositories. Since now Hilt only knows how to create this database instance, but not yet how it should create the repository instance, we still need to define that. But to create the repository instance, we need this database instance. As you can see, we need that here in the constructor. So that's why we first provided the database and now the repository. But the order here really doesn't matter. So same step as before. Provide to-do repository this time. And this time we don't need the context to create the repository. Instead, we need our database instance. So we pass this here, which is a to-do database, and returns a to-do repository. So here, Hilt now will automatically detect, okay, we provide a to-do database here. So it will know and pass it here behind the scenes. So we just say we return to-do repository implementation here and pass our db.dow. And that's now how we create a to-do repository given our database instance. And now we have all the dependencies we need in our project. Since Dagger now knows how to create a repository, we can simply inject this in our future view models. Okay, so far so good. The next step is to implement the view models. On the one hand, we have a view model for our to-do list screen, and we have a view model for an add edit to-do screen. The screen on which we will add a new to-do or added an existing one. So in the end, usually in your apps, you have one view model per screen. If you have like an activity fragment architecture and not Jetpack Compose, then sometimes you also have a so-called shared view model, so that you bind your view model to your activity and not to your fragments. And then multiple fragments can use the same view model instance. It's not the case that you do that this often, but sometimes it does make sense. Sometimes you want to share some data between different fragments, and then you can also use a shared one. And here in Jetpack Compose, we usually use one view model per screen. You're totally fine with that if you do it like that. What is now actually the job of the view model in MVVM? On the one hand, business logic. That is what you've probably learned in the 100 seconds MVVM video. However, it also contains a little bit more. Like, it contains our state of the specific screen. So what is state? State is basically how our UI looks in a given moment. So basically the data and values our UI reflects in a given moment. So state in the end is a value that can change over time. So if your background color can change over time, then that would be state. If you have some kind of text field and the content of that text field can change, the content of that text field would be considered state. And like the sum of all of these single states would be considered our UI state at a given moment. And that is what our view model contains and keeps. The advantage that we put this in the view model is that our app will survive screen rotations. So in case you're not familiar with that, when we actually rotate our device, then we speak of a so-called configuration change. So that means the activity is actually recreated. And if you put these state variables, like let's say you have a text field state, and you put these directly in the activity, then that would be reset after a screen rotation. It could also be like you switch from light mode to dark mode. That would also be a configuration change, or you change your device's language, then it's also recreated. Like there are different scenarios where your activity is recreated, and if you don't put your state in a class that outlives the activity of fragment lifecycle or composables lifecycle here, then it will just be lost because it will be reset to the initial value since you initialize that in your activity or fragment. And by just using a view model, we make sure that this can't happen so that the same values or the values we actually have when we rotate our device will just be kept, and our UI will then automatically be notified about the current values after a screen rotation. So let's actually jump into our UI package and create a package for both of our screens. First of all, to-do underscore list. And in that, we're going to have a to-do list view model. And that will be a class. Every view model in Android inherits from view model. That just gives it some lifecycle specific behavior. And since we now want to inject the repository using Dagger Hilt, we do this in the constructor using this inject keyword or annotation. So the way this works, we import inject here. We pass the repository instance here of type to-do repository. And for ViewModel specifically, we also need another annotation here, which is Hilt ViewModel. So, quite complex. How does it work? As soon as we annotate something like either a constructor or a property with @inject, that will tell Dagger Hilt, okay, please look into your modules. If there is any type or if there's any dependency of this type that you know how to create and that it can pass behind the scenes for us here. So we now don't create this ViewModel instance on our own. Instead, Dagger Hilt will generate code for us that already knows or that already created this instance for us and injects this into our composables later. And since in our app module, we defined how to create a to-do repository, Dagger Hilt will know, where's my ViewModel? Here. Will know how to simply pass it here in the constructor behind the scenes. So again, we don't create this instance. It's all Dagger Hilt, which will do this in generated code for us. So in here, we will now put business logic. We will now call our repository functions, and we will now have our state variables. Okay, what kind of state do we actually now need here? Let's first think about the to-do list screen. What kind of state would make sense there if we open this here? Then in the end, that's really just a single variable in this case, and that is the list of to-dos that we actually want to display. That's the only value on the screen that can potentially change over time, because of course, at the beginning, the list is empty, then we load it from the DB, we update the state with the list that we got from the DB, and then we reflect that and show that in the UI. So we can just get that from the repository, val to-dos is equal to repository get to-dos, and that returns a flow which we can then easily transform to compose state in the UI layer by using collect as state. But that's a composable function and we need to execute that in the UI. But we also need something else, and that is a so-called channel, or if you want, you can also use a shared flow. So let's open the app again here. A channel is actually used if we want to send one-time events or shared flow. Both will, in the end, do the same thing. Channels are meant to be used with single observers, and shared flows can be shared, so multiple observers are acceptable there, but you can use both for the same use case. So what does one-time event mean here? It means, well, a thing that only happens once, like if we want to show a snack bar here, if we want to undo that. Like these are one-time events that we actually don't want to assign to a new state, because as soon as we have some kind of state in a state variable, then that means the state will also be kept on screen rotations. But if we actually delete this to-do item and we show the snack bar, which is just a one-time thing, and we rotate the device, we don't want to see the snack bar again. But if we would have that as a state, it would fire off again, and we would see the snack bar again for maybe error messages we had in the past, or deleted items we had in the past. So that's why we need a channel here to just send these one-time events. And another use case would be to navigate. If we actually click this button here, then what will happen is our view model will send a navigate event to our UI, and the UI will then call the navigate function of our nav controller. That's also just a one-time thing. When we click the button, we just want to do that once. We don't want to do it again on screen rotations. So just to make this clear what one-time events here actually are, I will here use a channel because we only have a single observer. Let's call this underscore UI event. I call this underscore UI event because this is actually the mutable version of that. So when we use things like stateflow or state, or in this case channels, then in the view model we always define a mutable version. So that's the version we can send events into. And then we also define an immutable version of that. So a version where we can send events into. And that immutable version will be exposed to the UI layer so that the UI layer can receive events but not send new events into that. So that's how it's supposed to be. We can set this to a new channel here. And well, now we need to define what kind of events we want to send into that. Since I called this UI event, these will be UI events. That's a class we don't have yet. So let's actually create a util package for that in our root package. And in that util package, I will create that UI event class. That will be a sealed class because we will have different types of UI events here. And that will just be a thing that we want to, just an event that we want to send to our UI, so our UI does something in the end. So either showing a snack bar, navigating, maybe popping the backstack, these things that are relevant for the UI layer, and yeah, that we want to send from our view model. So something we could start with here is just a very simple object to pop the backstack. So that will be an event we send to the UI when we want to navigate back. So object pop backstack of type UI event, doesn't need any parameters. Then we want to have this time a data class navigate, which will be an event we send from the view model to the UI when we want to navigate to a new screen. That needs the route we actually want to navigate to. And we will have a final data class show snack bar. That will actually take the message we want to show in the UI in the snack bar, and it will take an optional action, which is a nullable string. So if we want to attach an action to that snack bar, which we want in our app, that undo action, then we can also attach that here to that event. And that's already it for this sealed class. We can jump back to our view model, import that, pressing Alt+Enter. And then we can expose an immutable version of this channel, or rather this channel as a flow, because then we can easily receive these events. So UI event, without an underscore now, is equal to UI event receive as flow. And then we can subscribe to these changes in our UI layer, and we receive these one-time events just once. Another thing that I always like to do with MVVM is that each screen also has a so-called event class. So with that, I don't mean this UI event. Instead, I mean specific events to the screen. And those will be events that we send from the screen, from the UI layer, to our view model when there is some kind of user interaction. So when we click a button, when we maybe want to reload the list, when we click something on the toolbar, those would be events that we would send from the UI to the view model, so the view model should do something. And this event class that we will create here in the to-do list package will just make this very clean and easy. That will be a sealed class as well, and we will call this to-do list event. So you just always call this as you call your screen, followed by event. And as I said, you do this for every single screen. And now for this event class, we need to think about what kind of user interactions could we possibly have on this to-do list screen? Well, we could, for example, click on this delete icon. We could, for example, toggle the done state of our to-do. We could click on an item, on a to-do item, to edit it. We could click on this floating action button to add a new to-do. And actually one more, we could click undo, which is also an UI event that we send to our view model. Not a UI event in terms of this UI event class, I mean an event of this class here. So let's start with deleting a to-do. So that will be a data class, delete to-do, and it will just get the to-do we want to delete, and we send that to the view model of type to-do list event. We also have another data class, which will be onDoneChange. So when we actually want to change the done state of a specific to-do, so if we want to toggle that, we need to first pass the to-do we want to do that for, and we need to pass the new is done state, which is a boolean. So the view model can in the end then update that in our database. Then we also want to have something, okay, that we actually can undo the deletion of a to-do. That will just be an object that doesn't need any parameters, because we will just cache the recently deleted to-do in our view model and then just restore it if we click that. So object on undo delete click of type to-do list event, and we also want to have a data class on to-do click when we click on to-do item to get to its detail view. And one final one is actually to just add a new to-do. So data class, or actually an object, because that does not need any parameters, on add to-do click to-do list event. So far so good. Now we can hit jump back over to the view model and implement a function on event. So that would be the function that we trigger from the UI given such a to-do list event. And in here we can now very easily distinguish what kind of event that is, and depending on that we just execute a different function or just some different type of code. So if that is on to-do click, we do this. If that is on add to-do click, we do this. On delete or undo delete, let's start with that, is delete to-do, which I actually want to rename to on delete to-do click. So I just had the cursor on that, pressed Shift F6, and that way you can rename this everywhere in your code. And I'm missing one event that is onDoneChange. Just like this. And now that's very, very clean and easy, so you don't need a separate function for every of these events in your view model. Instead, you just have one event function, and that handles them all. So let's actually start with one of the most simple ones, and that is on add to-do click, because all that should really happen there is that we send a navigate event to our UI that we now want to navigate to the add edit to-do list screen. And for that, I actually like to also have another object in our util package, which just defines our different navigation routes. Will be an object and called routes. And here we will define our two routes that we have. On the one hand, that is to-do list equal to to-do list and const val add edit to do. Just like this. And then here in on add to do click, we can say that we actually want to send an event into this shared flow, we use a channel here, right? Yeah. We want to send an event into this channel or shared flow if you use that. So we can say UI event send, that is how we send something into a channel. And we want to send a UI event dot navigate. And here we can now specify the route we want to navigate to. That will be routes added to do. When we click that button, we want to get to that route. I think that's pretty clear. We still get an error here because these event, these send functions of these UI events of channels need to be executed in a coroutine. So since that is an asynchronous call, we need to first launch a coroutine. If you're unfamiliar with that, I really recommend to watch my coroutines playlist. That will teach it in detail. But for this scenario here, what we basically want is we want to have a separate function to just send an event into this channel. You will see how this works. Private function send UI event. Here we want to be able to pass such an UI event. Oops. And here we can launch a coroutine. We can do this using ViewModel scope. So that is just used to bind the kind of lifetime of this coroutine to our ViewModel lifecycle. So if we do some kind of asynchronous call, like let's say you want to make a network call and your ViewModel is cleared, then you actually want to stop executing that network call, that ongoing one. And that's what the scope will do here. So it will determine, okay, if the ViewModel is cleared, all the coroutines in that scope will be canceled. So we can say that launch to launch a new coroutine. And in this block, we can now execute these so-called suspend functions, as we also have with our room database. So we can take this and simply put it in here. And now you can see the error is gone because we execute this in this launch block. If we click on this and click Control Q, you can also see that's also a suspend function. So that's why we got that error, because it needs to be executed in such a launch block or in another suspend function. Now we can go in here, call this function, send UI event, and we say, actually, we don't want to hardcode this to UI event navigate. Instead, we just want to pass the event we pass as a parameter. And then we can pass that here to navigate to our edit to do screen. Another easy one is on to do click, because in that case, we also want to navigate to add edit to do, but with a minor difference. And that is that we also want to attach the ID of the to-do item we clicked on. Because if we click on an existing to-do item, we of course want to load that item on the add edit to do screen, because otherwise it would just have empty text fields. It would assume we want to add a new to-do, but if it exists, we want to edit the existing one instead. So what we do is we say routes add edit to do, and we just add a to do ID argument here. And we can say that will be event.todo.id. So that is what we basically pass here. Well, what can we do next? When we click on undone change, so when the checkbox is actually toggled, then we want to just update that change in our database with the new Boolean. So what we can do is we can say ViewModel scope.launch, because to execute our database functions, we also need a coroutine. These are also suspend functions. And in here, what we want to do is we want to say repository. Now we access our repository, which accesses our database. And we want to insert a to-do. Well, we don't want to really insert a to-do because it already is in our database. We only want to update the done change, the done state for that. However, if you remember, in our to-do DAO, we defined this on-conflict strategy replace. So if we try to insert a to-do that already exists, we will update it instead. And that is what we will make use of here. So we will use the to-do we actually passed for the event that will come from our UI layer, and we copy that. So we keep its ID, that way it will be updated. And we just say is done is now equal to event is done. So that will be the new is done state that we also received from the UI. So whether this checkbox is now checked or not. And then what's missing? Well, we still need to be able to delete a to-do and undo that deletion. Let's start with deleting a to-do and also launch a coroutine here. How would we do this? We of course want to say repository, delete to-do, and we pass our event to-do. That is already enough to delete it. However, we need to also consider something here, because we want to be able to undo that deletion. And how do we know which to-do we actually want to undo when we click that? Because of that, what I will do is, up here, we will have a private var deleted to-do. And that is a nullable to-do. So that is used to cache the recently deleted to-do. And if we then click undo, we simply take this and insert it back into our database. So here before deleting it, we want to say deleted to do is event.todo. And then in undo delete click, we can simply restore it. However, we also want to send a UI event here, which will be show snack bar, because we want to show that snack bar to also be able to undo it. The message will be to do deleted. And the action will be undo. And then our UI will receive that event and show the snack bar. And then finally for on undo delete click, we also want to, we actually first want to check if the deleted to do is not equal to null. And if that's not the case, we want to also launch a coroutine in ViewModel scope again. And we just want to say we insert that to do back into our database. Oops. And that is already everything for our to-do list view model. The next step would be to implement the to-do list screen. So just this screen here in Jetpack Compose. It's really not a difficult screen. We just need to define such a to-do item composable, which we will do. We need a scaffold to display this floating action button, but that's already it for this screen. And then after that, we will implement the add edit to do view model and the add edit to do screen. So let's actually take a look at our UI and think about how we will structure this. In the end, we just have, for such a list item, we just have a row, which contains this box and this checkbox, just horizontally aligned. Then here we will have a column inside of that row, which contains another row for these two items and just another text here. That's how that is arranged. And we're now going to jump into our code and apply that. So in to-do lists, we create a new Kotlin class of file. Will be a plain file, just like we always do it in Jetpack Compose, called to-do item. And we can create a composable called to-do item. And this to-do item will take 3 parameters. On the one hand, the to-do item from our database, our to-do entity that we actually want to show in the UI. Then it will actually need on event as a Lambda function, which will take a to-do list event and doesn't return anything. So you will see why that is helpful. I won't go into that here, but you will understand that in a moment. And we will be able to pass a modifier, which should usually be possible for custom composables, just like this. Then, as I said, the very outer container will be just a row where we apply our modifier, actually the modifier we passed, and we make sure that we set the vertical alignment to center vertically for that row. Then inside that row, as I said, we will have a column here and a checkbox. So on the one hand, we have our column, for which we will apply a modifier of modifier.weight1f. With that, we just make sure that the column here, the width of the column, will just take all the space it can get, while the remaining elements will just take the space they have, or they need rather. We also set the vertical arrangement to center. And then finally in that column, we will have another row, as I said, which will contain this text and this icon. So a row, we say modifier is modifier dot fill max size. Do we actually want to fill the maximum size? No, I don't think we want that. I think we don't even need a modifier. So I think we're pretty fine just saying vertical alignment and set that to center. And in that row, we will just have our text that displays the to-do title. So we say text is to-do dot title. We want to set the font size to maybe 20 SP, import SP, and we can say font weight is bold. Then let's have a little bit of spacing between the text and the delete icon. ATP, import DP, and then we have our icon button. It will display an icon, which will be icons default delete. And content description will be delete. When we click this button, we will now call our onEvent function with onDelete to-do click, because that's what we want to do. And we pass our to-do statement. So now the cool thing about having our to-do list event class is that all we really need to do for our child composables, like this is not the parent composable, this is not what reflects our whole screen. This is just a single item. And in a more complex layout, you can have tons of these single items, and these could also contain like other custom composables that you implemented. And all of these now only need this onEvent function to propagate events up to the parent screen, which then talks to the view model. If you don't do this, then you would need to have a callback function here for every single thing a user could do. So we would need a parameter for actually clicking the to-do item. We would need a parameter for deleting it. We would need a parameter for toggling the isDone state. Having this event class, we only need this onEvent function for every single of our child composables, and that is pretty cool. Then, however, if we scroll down, we're not done yet. For this column, we now have this row with our title and the delete icon. Below this row, we want to have a little bit of spacer with height of ATP. And then, actually, we first want to check if the to-do description is not null. So since that's an optional parameter, we want to check if that actually exists. If it's not, we want to apply our spacing and another text with the description. So here we can just pass it. And the final thing that's missing is the checkbox. That will be in the very outer row. So that's right here. We can say checkbox. The checked boolean here will be to-do is done. And on check change, here we get the new is checked state, which we can then pass to our onEvent function, saying on done change, and we say the new one is now is checked. And we actually also want to pass the to-do we actually changed the state for. So that's it for our to-do item. The next step is to implement our to-do screen, to-do list screen actually, also here in this package. To-do list screen, plain Kotlin file, composable to-do list screen. Which parameters will that need? On the one hand, we need a function on navigate, which we will call whenever we want to navigate from this screen to another screen. So these screens themselves don't handle the navigation. That will be done by the parent composable, which will be purely for navigation, which will contain the nav controller instance. So that way we don't need to pass this instance down to all the very lowest level composables here. Instead, we just have all the navigation happening in a single file, basically. And we just propagate up these navigation events. So those will be UI event, navigate, and we pass unit here. And what we of course need is our ViewModel reference, because now we are in the UI layer. Now we're actually talking with the ViewModel, because the ViewModel now contains the state of this specific screen, so that we also want to be able to retrieve that state when we rotate the device, so that it's actually not lost. So ViewModel, to-do list, ViewModel, and since we use Dagger Hilt to inject that ViewModel, we just need to say Hilt ViewModel. And that will automatically pass this ViewModel here for us. We don't need to pass this on our own or create it on our own. Dagger will do all that for us. If anything regarding Dagger here is unclear, I know this is often hard to understand if you've never faced that before, and just ask below and I will answer your questions. So first of all, we want to retrieve our to-do list state. So val to-dos, we get that from our ViewModel.todos, which is now a flow, but we need it as a compose state, because only that will trigger recompositions so that everything is updated on our screen. Collect as state, and we need to provide an initial value here, so just the value we start with, and that will just be an empty list. Then the next thing we want to do on pretty much every screen is we want to collect these UI events. So for that, what we need is we need a so-called launch defect block, passing true as key 1 here. So what that will do is it will basically execute this code here independently of this composable function, because this composable function is called every single time our to-do list screen updates. We of course don't want to subscribe to our UI event flow every time the UI updates. Instead, we only want to do that once when we actually show it up the first time. And that's what this launched effect block will take care of. Here we can say ViewModel, UI event, collect. And that will now be triggered for every single event we send into this UI event channel. So every time here, we call send UI event and we call this send function, we now trigger this block of code here. And now depending on what this event is, if it is maybe show snack bar, we want to do this. If it is navigate, we actually just want to call on navigate with this event. And if it is pop backstack, we want to actually also call a function to pop the backstack. Oh, actually, we don't need this here because on this screen, we never want to pop the backstack. We only want to do that in the add to do screen because when we insert a new to do, we automatically want to go back to the list screen. So here we don't need this. We can just say else unit. So else we don't do anything. So what happens if we receive the snack bar event? Well, then we want to show a snack bar, obviously. And for that, we can do that. For that, we can actually have a scaffold state with which we can do that easily. So, well, scaffold state is remember scaffold state. And then we can use that to say scaffold state, snack bar host state, show snack bar. And the message we attach will be event.message, and the action label will be event.action. Now, how do we detect if we actually clicked on undo here for the snack bar? Well, we get a result here. And after that, we can check if the result is snack bar result action performed. So that will be the result if we actually clicked on the undo button. If that's the case, we want to say ViewModel on event. That's now an UI event that we send from the UI to our ViewModel. And the event that we send here will be to-do list event dot on undo delete click, because that's what we did in this case. When we click on this snack bar undo button, then we just want to send this undo event to the ViewModel, and the ViewModel will then take care of that here. That's how this will always work. You can use the template in any of your projects, just having this event class for every single screen. Then this onEvent function will always be the same. You call that whenever the user does something on your screen. And when the ViewModel wants to send a UI event back to the UI, you just create this UI event class and different types of that for whatever you need that. So down here below this launched effect block, we will now have our actual content, which will be a scaffold. Here we pass our scaffold state, and we want to make sure we have a floating action button. Floating action button. Well, when we click on that floating action button, we also want to call ViewModel on event. That's again just something the user does on your screen. This time it will be on add to do click, because that's what we did. And the content of that will be an icon, icons default add, just to get that little plus icon. And the content description will be add. And that's already it for this floating action button. In the scaffold, we now only want to have our to-do list, our to-do list. So a list of our to-do item composables, which will be a lazy list, lazy column. I want to say modifier is modifier fill max size. And in here, we will have our items block. So I will use this one with a list of t, so we can just pass our to-dos state here, which we actually, yeah, let's just pass to-dos value here to get the actual list from that. Then we get the to-do item for the current composable here. And we want to have a to-do item here. We pass our to-do. And the cool thing is, now for all your child composables that you get, that you actually have on your screen. On this screen, we only have the single to-do item. But you remember that we have this onEvent function in this to-do item, which we here just trigger for every single action. Like when we click on the delete icon, when we click on the checkbox. And for these things, we now send these events up. And the cool thing we can now do is, because our view model directly receives these events, we can say view model on event. That's super clean. So you don't need any crazy lambda function here. You can just delegate this event that we propagate up directly to the view model. And that's super cool, super clean here. I always use this approach in my projects because it just works so well and doesn't require a lot of code. One thing we need here is a modifier, compose one, and to make sure to fill the max width. Want to make it clickable, because when we click on our to-do item, we want to say view model on event on to-do click, and we clicked on this to-do that we got from the list. And let's add some padding of 16 dp and import that. And that's it for our to-do list screen, I guess. Yeah. So now that is implemented. We sadly can't try this out yet. I mean, we would see something, but all we would see is the floating action button because our database is empty, so we wouldn't load any to-dos. And yeah, so we first actually need to implement the add edit to-do list screen before we can add new items, before we can see them in our to-do list screen. Okay, next up we have our add edit to-do screen. So let's go to our UI package, create a new package for that, add edit to-do. And let's also create a view model for that. Add edit to-do view model. Select class, make sure that inherits from view model. And we just have the same procedure again as we had for the to-do list one. We just have our Hilt view model annotation, so Hilt knows how to inject its dependencies into this view model. And this inject constructor with all the dependencies we need for the add edit to-do view model, like that. So let's start with Hilt view model. But then have inject constructor, import inject, and we again just need a reference to our repository. So private val repository of type to-do repository. And yes, we actually need another dependency here. Well, what could that be? We only provided 2 dependencies in our repository, and the repository already uses the database. We need the so-called saved state handle. So we can actually say saved state handle of type saved state handle. So what is that? That is, yeah, kind of a key value object. It basically contains a bunch of state variables. So on the one hand, we could use that to restore a view model state, maybe after process death. But on the other hand, what's really useful is that this contains our navigation arguments. So on this screen, we actually have this navigation argument, the to-do ID, which we would actually like to load from the database if we clicked on a to-do to open its details here on this page. So Hilt will do all that for us behind the scenes, since we use inject here. We don't need to provide this on our own anywhere. It will just work magically. So what do we need in here? In here we now need our different states. Again, as we did here for the to-do list view model, here we only had the single state. So that wasn't really a compose state because we got the flow from the room database. But here for the add edit to-do list screen, we need a separate state, like multiple separate states. On the one hand, we needed the to-do title. So if we enter a title in our text field, we want to change the state for that. We need the same for the description. And we actually need, a state for the actual to-do that we potentially loaded here if we clicked on an existing to-do. So let's start with that. Actually, that will be a public variable, to-do. And that's equal to immutable state of a nullable to-do here, because if we want to add a new to-do to our database, then it will simply stay null. And we want to make sure that we have a private set here. That means we can only change the value from within our view model, but we can read it from outside. It's basically for the same reason as we had these two versions here, so that we only expose an immutable version of these states or flows or channels to the UI. Then we want to have a variable for the title, which will be a mutable state of empty string by default, private set, and we want to have a variable for the description, which will be also a mutable state of empty string, private set. So those were all of our state variables. Let's further think what comes next. Do we need some kind of events we send from the view model to our UI? Yes, we do need that. We again need this UI event channel, so we can simply copy this, paste it here. What kind of events would we like to send? Well, for example, if we actually finish saving a to-do, so when we click the check button, we validated the inputs, everything goes well, then we want to send the navigate event, or the pop backstack event rather, to the UI, so that we're navigated back to the list screen where we then see the added to-do. So let's first override, or rather implement the init block, which will be executed as soon as our view model is initialized. And here we first want to check, did we actually open this add edit page by clicking on an existing to-do or by clicking on adding a new to-do? Because if we want to open, or if we open this from an existing to-do, then we want to load this to-do from the database by its ID. So then we would get the to-do ID using our saved state handle. That is an integer. The navigation argument is called to-do ID. And if that's null, we simply want to, oh, that's never null, because we make that, we don't make it a mandatory argument, or I think we have to. Not sure. I think we can make it an optional one and just have a default value, because for integer values we can't pass null here for the arguments, but it should work like that. If we take a look here, I made it an optional one, but we actually always pass it because we will define a default value of -1 for the reason I mentioned. We can't have nullable integers, and if we didn't click on a to-do, then we will simply pass -1 for the to-do ID, and that way we can detect if we actually want to add a new one or open an existing one. So if this ID is not equal to -1, that means we clicked on an existing one and we want to now load this. So we say ViewModelScope.launch, and we say our to-do, our state, is equal to repository get to-do by ID, and we simply pass our to-do ID. We do get an error here because the to-do ID could theoretically be null, which will never be the case here, so we just assert it's not equal to null here, and we still get an error. The mutable state, oh, because I set these equal to this, we actually want to say by mutable state of and import this delegate way here. That way we can easier assign the state without using .value all the time. And then the error is gone. We also want to make sure to assign the corresponding title of that to-do to our title state. So title is equal to to-do.title. Let's actually make the null assertion here and remove this one. Then why do we still need this? Oh, because I want to, let's do it the other way. Let's say that let here, we read the to-do, and then we're sure it's not null. We can say title is to-do title, description is to-do description, and finally, the description is actually, yeah, if that doesn't exist, we pass an empty one. And finally, we say this at added to-do view model dot to-do, so our to-do state is the to-do item here that we read from the database. So I hope that makes sense. That was a little bit confusing, I think. So we just read the to-do ID. If it's not -1, that means we opened the to-do from an existing to-do. So we clicked on an existing one and we want to load its data into our UI. So we load that with our repository function, assign the to-do's title to our title state, so it's showing up in our text field. Doing the same for the description, it's optional, so if this doesn't exist, we just assign an empty string to the description state. And finally, we assign the to-do to our to-do state here. So now we have this init block. What is the next step? The next step is to do the same thing again as we did here in the to-do list view model. We want to have this on event function in the add edit to-do view model. As I said, that will be the same for every view model, at least every view model that is bound to a specific screen. So function on event. And which events do we pass here? Well, we need a new event class. So we go to our add edit to do package, new class, seed class, add edit to do event. And here we now need to think about it again. What kind of events we could possibly send, or what could the user possibly do in this add edit to do screen? On the one hand, they could change the text content of our title text. So let's call it on title change with a new title. Add edit to do event. Same for the description, on description change. Description. Then we could click on save to do. So object on, or rather on, how do we call this? On, yeah, let's call it on save to do click. Add edit to do event. And let me think about it. Do we need something more? No, I don't think so. Let's go back to the view model. Now use this add edit to do event. And again, just have a when expression and check what that event is. If it is on title change, we simply want to change our title state to event title. If it is on description change, we do the same for our description state. And finally, if it is on save to do click, what do we want to do in that case? Well, we want to launch a coroutine again, because now we want to insert the to-do into our database. But first we want to check if the title is actually not empty, because only then we want to insert it into our database. So if title is not blank, we say send UI event. Let's actually copy over the function from here, the send UI event function. Paste it in our add edit to do view model. Call it here and say the event will be show snack bar. I want to say message. The title can't be empty. And we return at launch. If that's not the case, we can simply insert a new to-do into our database. So repository, insert to-do, and we construct a new to-do. Actually, we don't want to construct a new to-do. Yeah, we do. So, new to-do. The title will be our title. The description will be our description. The is done state will be either the is done state from our to-do state. So to-do is done. So if we loaded a to-do, then we want to keep the is done state at whatever it is. If we didn't, then this will be null. We just want to say false, so initially the to-dos are not checked. And the ID will be to-do ID. And if that is null, then Room will generate a new ID. And after we did that, after we finished the insertion here, want to send another UI event, which will be pop backstack, because then we want to navigate back to the to-do list screen. It's really that easy. So let's finish this off by implementing our add edit to-do screen in our add edit to-do package. So now we implement the UI that talks to this view model that we just created. So add edit to-do screen, select file, and make that a new composable add edit to-do screen. That will again take lambda function that we will trigger from our view model. This time only on pop backstack when we receive that backstack event. We don't really need a navigate event because we don't want to navigate anywhere. We just want to pop the backstack here. And we need a reference to our view model here, of course. And also equal to Hilt view model. So Hilt automatically injects that here in our composable. Well, we again need a scaffold state to be able to show snack bars. So remember scaffold state. Then as on the other screen, we have a launched effect block to collect these UI events that we get from our view model. So we can say view model, UI event, collect, get the events in here, and we can check whatever that event is. If it is pop backstack, we say on pop backstack, so we just trigger our callback function. So we propagate this event up to the navigation composable. So we can then pop the backstack there using our nav controller. And we want to check if it's a snack bar event. In that event, in that case, we want to use our scaffold state, snack bar host state, show snack bar. Message will be, what will it be? Event.message. And the action label is event action, which we actually don't have on the screen. We can still assign it here. So now we have that. Actually, let's also have the else case here, so we don't get this warning. Down here, we will now have our scaffold, where we pass the scaffold state that we created above. I want to add a modifier here, compose one, fill max size, and I want to add a little bit of padding of 16 dp. And import dp. And we, of course, also need a floating action button here on the screen to be able to save the new to-do. So floating, come on, floating action button. Here we pass a floating action button composable. Well, when we click on that, we again want to fire off the onEvent function of our view model, which will be add edit to do event this time, .on save to do click. And in here we use an icon, icons default save, or is it, it's called check, yeah. And the content description will be save. So that is pretty similar as on the other screen. In here, we basically now only have our two different text fields. And I think that is already it. So let's create a column. Modifier is a modifier, fill max size. And then in that column, we will just implement two text fields. So text field, the value will be view model title. So the first one will be our title text. On value change, in that case, we want to say view model on event. That is a normal user event on our screen. We want to say on title change and pass the new title here. Let's also say we have a placeholder here, just as a little hint. Will be normal text, just title. Then what else could we have here? A modifier. Modifier fill max width, definitely. And that's it for this text field. Then let's add a little space of height 8 dp. And then we copy this text field, paste it down below. View model description this time. On description change the placeholder to description. Description. Modifier will stay the same, and yeah, here we could also theoretically say single line is false and max lines is 5. So we could also have a little bit of a longer description. But other than that, that's already it for this add edit to do screen, which is a very simple screen. Now that we have both our screens, now that we have all of our view models and we have our repository, the only thing that's missing is the navigation, which is luckily very easy with Compose. I will put it directly in main activity here. In a more complex project where you also have other stuff in main activity, I would create a separate navigation composable for that. I will leave that away here. And one thing we also need to consider is that we annotate this activity with Android entry point. That is an annotation that comes from Hilt and is necessary as soon as we want to inject dependencies in an Android component. An Android component could be an activity, it could be a fragment, could be a service, all that stuff. If that's the case, if you want to inject dependencies in that, like we want it here with our view models, you need this annotation. If you want to inject that in other classes, then you don't need that. So in here, we basically just define our nav controller first, which we use to navigate by remember nav controller. And then we have a nav host where we pass our nav controller. And we want to also define a start destination, which will be routes to-do list. And then we open this lambda block here. So in the nav host, we now define our different screens we have by using these composable blocks and defining a route for that. The first one will be routes to-do list. And here in this block, we simply call that screen composable, which will be to-do list screen. And in on navigate, well, what happens there? We simply want to say nav controller dot, actually in a lambda block, nav controller dot navigate to it dot route. So we get this UI event in here, and then we use the nav controller to navigate. And finally, one more screen. That will be another composable. The route will be routes.add to do here. And we want to have an argument here, which is the to-do ID that we want to be able to pass to the screen. So we say to-do ID is equal to to-do ID. So whatever we then pass for the to-do ID will be replaced here and passed to our other screen. So arguments will now be a list of nav arguments. And in here we define how our argument looks like. So let's do that here. Name is to-do ID. So this must be the same as this. And we can customize this argument. We want to say the type of that is nav type.inType because the to-do ID is an integer. We want to be able to pass integers here. And if we don't pass a to-do ID, if we want to directly create a new to-do, we need to pass some kind of default value to detect that. And that will be -1, -1 as I showed you in the add to do ViewModel. So here, if this to-do ID is not equal to -1, that means we passed 1 and then we load it. If it is -1, well, we don't load it. So here we open the block of code and we have our added to do screen on pop backstack. Well, in here we can just say nav controller pop backstack. It's that easy. And I guess that is everything for our project. It was quite a big project here, at least for a single video. But I hope this was helpful. Let's actually launch this app, and I am excited if I messed something up and I forgot something, or if everything works. And the app is opening. It's at least not crashing, which is usually a good sign. Let's try to add a new to-do by clicking on our floating action button. We get to our new screen. Let's enter test title here. Test description. And we then click on this check mark and the title can be empty. Okay, it seems like I messed something up there. Let's see, add a to-do screen. When we enter title, we send this on title change event. And in the view model, what do we do when we receive that event? We assign a new title to that. And here we check if the title is not blank. Oh, actually, if it is blank, then we want to show the snack bar. Of course. So it is working as it should. So the title is assigned correctly, but that was just a messed up statement. Let's try that again. Test title and test description. But then we've already seen that the snack bar works. So if we click check, then there is our to-do. If we check that, if we minimize, actually close this app and the other one as well, and then relaunch that. That was the other one. This one. Oh, that was the other one again. So it is the first one, this one. Yes, there we go. It's still checked. It's still in there in the list. If we delete it, to-do deleted, we can click undo. If we rotate our device, then you can see it also survives screen rotation, which is one of the purposes why we should use an architecture like MVVM. So that is working pretty well. Let's actually also check if we can update this existing to-do. If we click on it, yes, the test title and test description is loading. Test title updated. Save that, and there we go. Then the title is updated, the checked state is still checked. And yeah, we can toggle that as we like. So let me give you a quick little recap of what we have done. On the one hand, we have started with our data layer. We defined our to-do entity, which is the table in our database, which contains whatever we want to save for one specific to-do item. Then we use that in our to-do DAO, in which we define how we access our database and what we want to do with it. We defined our to-do database class, which is just for room to define, okay, this is how a database would look like. These are the entities we want to include. This is the version. And then room will generate all the necessary code behind the scenes for us so we can use it. Then we defined this to-do repository interface, in which we just defined the same functions of our DAO again. This looks not necessary here. In this project, it is not necessary, but the bigger your project gets, the more these repositories will pay off, since they access your different data sources. If you not only have a database, like also an API, then the repository would also access the API. That is its job. Then here's the implementation of that, which is also very easy here. We just use our DAO and we call the corresponding functions on it. We have the app module, for which we use Hilt. So here we basically provide all of the dependencies, all of the objects we want to be able to inject somewhere in our code, which is just our to-do database and repository here in this project. We have our to-do list screen, for which we define this to-do list event class. That is used to send events from the UI to our view model for this side of the communication. And we have the other side of the communication, which is this UI event, which we send from the view model to the UI when something in the view model changes, like popping the backstack, navigating, showing the snack bar, and much more if you need that. In the to-do list view model, we then have this on event function, which we trigger from the UI when there is some kind of user interaction. So we send these events here and then distinguish whether this event is on to-do click, if we clicked on add to-do, and so on, and just do some different stuff here. And the same actually in add edit to-do view model. It's really the same. So you can use this kind of template in all of your projects. As I said, just have a repository, and for each screen you have an event class, you have a screen composable with potential child composables, and you have a view model that receives these events and sends events back to the UI in form of UI events. So I think this actually serves as a pretty good course now for any Android beginners who just learned the Android basics and now want to learn a real architecture, which is, you have to know that if you want to make real apps. It's mandatory. There is no way around an architecture. So this is super important what you have learned here. Now it's also time to be proud that you actually followed through this video. If at some point you want to actually take this to the next level, then I suggest you to watch this video, which is about making a dictionary app with clean architecture. So that is, some more concepts on architecture that are basically on top of MVVM that will, even make your app architecture cleaner if your app grows.